Hello viewers, welcome to the eMath learning platform by Peter Ekaja. I am going to take you through three-dimensional geometry, and this is specifically for the O-level math students. Now let's go direct and first define what we call geometry. Now geometry is the branch of mathematics that deals with the study of shapes, sizes of objects, their properties, and their relationships. Now to you as a student, you're expected to understand how to calculate the length of a given side of a given figure. You also expected to be knowing how to find the angle between a line and a plane, to find the angle between a plane and a plane, and finally to calculate the volume of a given figure. Now we are going to look at a few examples of shapes which are three-dimensional. And a few examples are pyramids, cuboids, cubes, cones, tetrahedrons, prisms, etc. Now let's begin with the right pyramid. Now this is how a right pyramid looks like. And we are saying consider a pyramid VABCD with a base as shown below. We should note the following. ABCD is the base of our pyramid. VAB, VBC, VAD, VDC are slanting faces with V as the vertex of our pyramid. Now, if the base ABCD is a square base, then all the slanting faces VAB, VBC, VAD, and VDC are equal in size. Now, if this base here that we have is a square base, then all the slanting faces you see, this face here will be equal to the other one behind will be equal to the one in front. But if the base is rectangular, then the opposite faces will be the only ones equal in size. For example, VBC will be equal to VAD, and VAB will be equal to VDC. That is what you have to note clearly. Another important point is that the height VO is perpendicular to both diagonals AC and DB. Now, as you see, AC is a diagonal, DB is a diagonal, and also remember that actually these diagonals are of equal length. So getting the length AC is as good as getting the length BD. So it means now looking at VO as the height, it is actually perpendicular to both of them, meaning it is perpendicular to this diagonal and it is also perpendicular to this diagonal. What does it mean? It means they form an angle of 90 degrees between themselves. Now let's look at one of the comprehensive examples. Now the question says a right pyramid has a rectangular base ABCD with sides AB as 8 centimeters, BC 6 centimeters, with slant edge 13 centimeters. V is the vertex of the pyramid. O is the point where the diagonals intersect. Now this is our pyramid we are trying to describe. What are the questions we have? Calculate part A, the length AC, part B, the height VO, part C, the angle between AV and the base, and part D, the angle between a plane VBC and the base. Part E, we shall have the angle between VAD and VBC. Now we shall also look at how to find the volume of this pyramid, and that will be our part F, as we shall see in the next page. Now let's look at the first question, part A. Now if you go back to the original pyramid, which is actually this, they want us to get the length AC, but you realize AC is one of the diagonals. So I simply extract this base here, which is ABCD. And being a rectangular base, we shall simply have our diagonal as AC indicated as you see here. Now I'm using an unknown X to represent the length AC. And if you're to look at this critically, we shall simply use this triangle ABC, and with the use of Pythagoras theorem, we shall be able to look for the value of X. So what are we going to say? We shall say X squared is equals to 8 squared plus 6 squared. The longer side, the length of the longer side squared, equaling to the length of the sum of the squares of the lengths of the two shorter sides. That is the basic of Pythagoras theorem. Now from there, you simply simplify. 8 squared is 64, 6 squared is 36. If you add them, you will get 100. So to get the value of x, we take a square root on both sides. And if you do so, in this case, we shall only take the positive value. It would be positive or negative 10. But in three-dimensional geometry, since we are dealing with length, we shall only take the positive value of x. And so we can conclude that actually the length AC is 10 centimeters. Now let's move on to the next question. Now the next question wanted us to look for the height VO. But if you go back to this original diagram here, VO is given here clearly. But for us to get it, we're either going to extract triangle VOB or VOC or VOD or VOA. Remember, they are all right angle triangles making a 90-degree at point O. So in this case, I'm going to consider triangle VOB. I'm going to consider triangle VOB, and if you look at it, we had OB as 5 centimeters, but how did we get the 5? How did you get the 5? Remember, to get OB, you will get a half of BD. But BD is the same as AC. But our AC is 10 centimeters. So it means BO will simply be a half of 10, and that will be 5. Then the height of V is what you're looking for, but you have VB as the slant edge. Remember, even the slanting edges for every pyramid will always be equal in length. All the slanting edges will be equal in length. So that is basically what we used. So I took 13 here, 5, and now we have our height. I'm representing it as h. You still use Pythagoras theorem. So this time it will be the shorter sides are this and this. So we shall have h squared plus 5 squared is equals 13 squared. And that will be our first step in Pythagoras theorem. Now if you square them, you will have h squared plus 25 equals to 169. Then you simply move the 25 to the right hand side and its sign will change to a negative. When that happens, we shall have 169 minus 25. And that gives you 144. Then to get h, you simply take a square root on both sides. So when you take a square root, we shall still take only one positive value. So h will be representing 12 centimeters. So we can conclude that our height of V is actually 12 centimeters. So that brings us to the end of part B. Remember, this is just our original diagram that we have referred to come up with this. As you can see, OBV is here, and that is what we have extracted out. Let's move on to part C. Now, part C, they wanted us to find the angle between AV and the base. Now, our base is ABCD. Our AV is this line here. Now what you do, if you want to get the angle between a line and the base, you simply trace for the common point. So you realize A is a common point for both line AV and the plane ABCD. Now being a common point, you now keep at this point A, then you draw a line of symmetry of the base. So a line that divides the base into two equal parts, which will be automatically the diagonal AC. But as you do so, we're interested in coming up with a right angle triangle. So when you reach O, then you realize we can connect up with a height such that we have a right angle triangle AOV. And the angle you're looking for is going to be at point A. Remember, AV is 13 if you want to use it, VO is 12, and AO is a half of AC. But remember, AC we got it as 10, so a half of 10 will be 5. So that is why I'm using AO as 5 centimeters. And VO is our height that we got previously in part B as 12 centimeters. From here, use SOHCAHTOA. You can simply use tan. So our tan theta will be 12 out of 5. You simply get theta as tan inverse of 12 out of 5. Should you press your calculator, you will come up with 67.38 degrees. And we are leaving our level of accuracy to 2 decimal places, at least 2 decimal places. Part D. Now part D wanted us to get the angle between the plane VBC and the base. Now when they talk about a plane and a plane, what you simply do is find out the common line. For example, when you look at ABCD as the base and you look at VBC, you realize they share 2 points. They share B and C, which B and C give us a common line. So what did you do? You come along this common line, come to our midpoint of that common line. Draw a line of symmetry of the plane VBC. So we shall have a line of symmetry here, which in my diagram here I indicated it with a dotted line. Then you also do the same, draw a line of symmetry from the same point for the base, which will be a dotted line passing through the origin here. So if it passes through O, now we are interested in getting a right angle triangle. So it means we are going to actually stop here and extract out triangle VOE. And our angle will be the angle between those 2 lines of symmetry. So this is how this triangle comes out. We have just extracted it from this. Then to find the value of theta, we simply use SOHCAHTOA again. So we shall say tan theta is 12 out of 4, which simplifies to 3. But theta will be tan inverse of 3, which gives you something like 71.57 degrees. And you write it to at least 2 decimal places. When I say at least 2 decimal places, it means either 2 or more. Let's move on to part E. Now part E, what does part E want? Part E wants the angle between VAD and VBC. Remember, they are both planes. What do you do? Now when you look at VBC and VDA, they only have one common point. Which one common point is V? So we expect the angle to be formed at the common point. What do? You stand at the common point, draw a line of symmetry of this plane, like I've done with this dotted line. Come and do the same here, draw a line of symmetry, and it also ends at this point. So I'm nicknaming these points E and F. Then simply join E and F, but make sure your line joining them passes through point O. So when you do so, you come up with triangle VFE. But remember, to now get this angle here, we are simply going to first get a half of the angle. We are taking this angle, we are calling it alpha, but remember this angle is also alpha. So why are we taking a right angled triangle? Because we want to simply use SOHCAHTOA. Now this is already given as 12 centimeters, we got it as the height, and OE is going to be 4 centimeters. Why? Because this distance from E to O is a half of the whole of this distance here, which is 8. Remember, FE is also 8 centimeters, so a half of it will be 4 centimeters. So we simply first get alpha, then after getting alpha, to get theta, because theta is the whole of this angle here, we simply multiply the value of alpha by 2. So we are saying tan alpha is 4 out of 12, which is a third. So you get the tan inverse, giving you 18.43. And to get theta, we shall simply multiply that angle by what? By 2. So let's look at how to get theta. We shall now say theta is 2 times 18.43, which gives us 36.86 degrees. And that will give you the angle between the 2 planes that they asked you. Now let's look at the last part, volume of the pyramid. Now this formula is stated in a mathematical book. You can always ask for it in case you don't memorize it. But it is a third base area times height. But remember, the base area is going to be the area of the base. Our length of the base was 8 and the width was 6. So it means we shall have a third times 8 times 6. Then times our height, which is 12. We got it in part, I think, part B of this question. So when you do that and calculate very well, you come up with 192 cubic centimeters as your volume. With this comprehensive example, allow me promise you that the continuation will be in the next tutorial for more examples. Thank you.